What's up, everybody? This is Tech G back with another video. And in this video, we're going to be talking about some popular machine learning algorithms. So let's get into it. All right, so let's be real. When you hear the words machine learning algorithms, you might picture some super complicated code, a chalkboard full of math formulas, or a robot plotting world domination. But here's the thing. Machine learning algorithms don't have to be scary. In fact, they're more like tools in the toolbox. And once you understand what each one does, when to use it, and how it works, at least at a basic level, you'll realize they're actually pretty intuitive. So in this video, I'm going to break down some of the most popular machine learning algorithms in an easy to understand way. And these are the ones that show up pretty much everywhere, from textbooks to real world applications and interview questions. So by the end of this, you'll not only recognize them, but you'll know what problems that they're good at solving. So let's proceed. All right, so before we dive in, let's go ahead and set the stage. A machine learning algorithm, this is basically a set of rules or methods that a computer uses to learn from data and make predictions or decisions without being explicitly programmed for that specific task. So it's kind of like a chef following a recipe. Each algorithm has its own cooking style and preferred ingredients, which are your types of data. Now, some are better for finding patterns and others are great at predicting outcomes. And some are just lightning fast at sorting through chaos. So let's go ahead and talk about some of these various machine learning algorithms. All right, so the first one we're going to talk about is called linear regression. And this is all about predicting a number. It tries to draw the best straight line through your data that represents the relationship between input, which is your independent variable, and output, which is your dependent variable. And a real life example of this would be, imagine that you want to predict someone's salary based on years of experience. Linear regression, it finds the line that best fits the data points, like the formula written on your screen right here, where it says salary equals A times the years of experience plus B. Now, exactly why is this great? Well, it's super simple. It's easy to interpret, and it's a solid starting point for many problems. Now, its limitations are, it only captures linear relationships, and it is sensitive to outliers. Next, let's talk about a decision tree. And a decision tree, this splits your data into branches based on questions like, is the person over 18? Do they own a car? Do they have a job? It just keeps branching until it makes a decision or a prediction. And a real life example of this would be a loan approval system. And it might include questions like your income level, your credit score, or your employment status. And basically the tree is going to lead you to a yes or no at the end of all of this to approve a person for a loan or not. Now, why is this great? Well, this is easy to visualize and explain, and it handles both numerical and categorical data. And there is no need to normalize or scale the data. Now, its limitations, it can overfit if the tree is too deep and is not always the most accurate on its own. All right, next we have what is called the K nearest neighbor. And this is all about finding similarities. It looks at the K closest data points to a new input and lets them vote on the result. So let's say you want to classify a new fruit as an apple or an orange. Well, the K nearest neighbor, it checks the closest fruits in the data set. And if 3 out of 5 neighbors are apples, then guess what? It's probably an apple. And this is how this is used in a real world example. So think of recommendation systems like Netflix or Amazon. They use the K nearest neighbor algorithm to recommend shows or products similar to what you and people like you have liked before. Now, why is this great? Well, there is no training step, so it's essentially lazy learning. It works well with very small data sets and is very intuitive. Now, its limitations, it can slow down with large data sets, and it is sensitive to irrelevant features or different scales. Then we have what is called the logistic regression. And this is used for classification problems like yes, no, or true or false outcomes. Now, unlike linear regression, logistic regression squeezes its output between 0 and 1 using something called the sigmoid function. So if the result is closer to 1, then it's going to likely produce an outcome of yes. If it's closer to 0, then it's going to be a no. In a real life example of how this is used, it can be used for predicting whether or not an email is spam or not spam. Now, why is this great? Well, it's simple and effective for binary classification. It outputs probabilities and it doesn't just do hard guesses, and it's easy to implement and interpret. Its limitations, it assumes a linear decision boundary and it doesn't perform well with complex relationships. Next, we have what is called the naive Bayes. And this is based on the Bayes theorem and assumes that all features are independent, which is often not true, hence the word naive. And it's all about using probability to guess the most likely class for a given output. And a real life example of this would be email spam filters. They really like this algorithm because it calculates the probability that an email is spam based on the words in it. And exactly why is this great? Well, it's extremely fast and efficient. It works surprisingly well with text data, and it can handle large data sets. Now, its limitations, it assumes feature independence, and it is not great for complex relationships. Then we have what is called the support vector machine. And SVMs, they try to draw the best boundary or a hyperplane between classes of data. It focuses on maximizing the margin between data points of different classes. So a real world example of this is SVMs. They are often used in image classification tasks like identifying handwritten digits. Now, exactly why is this great? Well, it is effective in high dimensional spaces, and it works well with both linear and nonlinear boundaries thanks to the kernel trick, and it's robust to overfitting. Now, its limitations, it can be slow on large data sets, and it's hard to tune its parameters. Then we have what is called the random forest, and this is an ensemble method. It builds many decision trees on random subsets of the data and averages the results. So you could think of it like crowdsourcing predictions. And a real life application will be using it for credit scoring or stock price predictions or even medical diagnosis. Now, why exactly is this great? Well, it reduces overfitting, is very accurate, and it can handle missing values and mixed data types. Its limitations is less interpretable than a single tree, and it's slower than simpler models. And then we have what is called the k-means clustering. And this is an unsupervised learning algorithm. Basically, it groups data into k clusters based on similarity without any labeled outcomes. So it's like going to a party and grouping guests by what they're wearing, even though no one told you who's who. How this could be applied in real life, it could be applied for customer segmentation for marketing, image compression, and identifying user behavior patterns. Now, exactly why is this great? Well, it's easy to understand and implement, it's fast and scalable, and it's great for exploratory analysis. Its limitations are, well, you have to choose the K manually. It's not great for irregular cluster shapes, and it is sensitive to initial starting points. All right, so I know that was a lot. So here is a handy little guide to help you choose the right algorithm if you're into this type of stuff. So go ahead and take a screenshot and get this in your life if you need it. Now, when it comes to algorithms, you got to understand that no algorithm is perfect and there is no best algorithm. Each one shines in specific scenarios, and the magic really happens when you understand the problem that you're trying to solve, you know your data, such as its size, type, and quality, and you try multiple models and then compare the results. Machine learning isn't about guessing the right tool for the first time. It's about experimenting, tweaking, and learning what works best. Now, to wrap all this up, at the end of the day, machine learning algorithms aren't mystical codes written in some secret AI language. They're just tools designed to help us find patterns, make predictions, and automate tasks in smart ways. So linear regression, this is your go-to for predicting numbers. Decision trees, this lets your data quote unquote speak for itself. K-nearest neighbors, this finds friendly neighbors. Naive Bayes, this keeps things quick and simple. Logistic regression, this gives you clean classification. SVMs, these are for perfectionists. Random forest, this is for the wise crowd. And K-means is the quiet type that discovers hidden patterns. So the more you practice, the more intuitive these algorithms will feel. And once you really get the hang of them, you'll start to see machine learning problems not as overwhelming, but as exciting puzzles waiting to be solved. Now that we got that out of the way, let's do some check on learning. So our first question is, which machine learning algorithm is best suited for predicting a continuous numerical value, such as housing prices based on square footage and location? Would this be linear regression, K-nearest neighbors, decision tree classification, or naive Bayes? And the correct answer is this will be linear regression. So linear regression is designed to predict continuous values based on the linear relationship between input values of your features and a target output. It's ideal for problems like forecasting prices, temperatures, or sales. The other options are either classification focused or based on probability. Next question. Which algorithm works by finding the most similar data points and using them to make a prediction? Would this be support vector machine, linear regression, decision tree, or k-nearest neighbors? And the correct answer is k-nearest neighbors. So this is an instance-based learning algorithm that stores all data and predicts outcomes for new data by finding the k closest training examples in the feature space. It's simple and effective for both classification and regression tasks. And our final question, what is a key advantage of using decision trees in machine learning? Is it they require a large amount of labeled data? They always produce better accuracy than other models? They are easy to interpret and visualize, or they can only handle numerical data? And the correct answer is they are easy to interpret and visualize. So decision trees are popular because they model decisions in a way that is easy for humans to follow. Their flowchart-like structure makes them interpretable. Now, unlike some other models, decision trees can handle both numerical and categorical data without extensive pre-processing.